Hello. Now we will see for the NABL scope how to fill NABL scope. Say example, I have received NABL scope for the mechanical this way. This is my thermal. Just hold on, let me take it outside. This is my thermal scope for the thermal department, and this is for the electrical department. Some different cases we will cover it here. Now see, in our application, you go at NABL scope, you will find some screen. You can select the lab name for which lab you are creating. This is my electrical certificate number. Now if you see the certificate number, it's C1267 for the mechanical. C1267. Then the issue date is 11 September 9:15. So I will take 11 September 2015, right? And issue date and due date is valid. It is for the 10th of September 2017. So I will go for the 17 September. This is my 17 September 2017. Then I will create for the lab the same way. I will create one more for the site also, right? The site C1269. Then this is my example. This is my issue date and this is my valid date, and I will create for the site. Same way I will go with the mechanical also. So C1269 is my certificate number. This is my issue date and this is my validity date, and I will create for the lab. And same way I will create one more for the mechanical. Just hold on. C1269. I just taking this, all these numbers are as an example. You just fill your actual number and dates. So I just taken the issue date and valid date here, and then I will create for the mechanical. I have created for the lab, that's why I am creating for the site. So this way, now we will see for the thermal. So now thermal, and again my certificate number of thermal. Say example C-1270 is certificate number, and this is my issue date and this is my valid date. Till what I have a valid this scope. I have created for the lab and I have created for the thermal. Again the same certificate number is my for the site also. So C-1270, and this is my validity, and this is, I will select it here for the site and I will create it. This is our first section of NABL scope. Now I have some uncertainties for every department, like see the mechanical. This hashes means, example, see at the bottom of this scope we have given some nodes. In that hash is for the this is indicated for the lab.v, this is indicated for the site. So what I will do, I will go at upstairs, one more. See, this is a dial gauges, right? Now what I will do, I will go here for the mechanical lab, and I will select that particular parameter. Type is not applicable for the parameter, right? So example, calipers. Now for the calipers, frequency is not applicable, so you left as a blank, then ranges are applicable. Now if you see this is a dial gauge, so I do not have the parameter dial gauge. So what I will do, I will go here, press Ctrl and click, open a new tab, select mechanical, then dial gauges, then plunger type, create it, refresh it, click here, enter, then you will be refreshed. Then if you see the dial gauges plunger type, then go at here, list count is 1 micron. So leave the frequency for the dimension, range is 0 to 1 mm. So 0 to 1 mm, select mm, then list count is 1 micron, so select 1 micron here, this is a micron, and what is my uncertainty is 1.0 micron, 1.0 micron, and select 1.0 micron here, and this is for the lab and lab, this is only for the lab. Right, now lab, this is a remark. Remark is what? Using ULM by comparison method. So using ULM by comparison method. This is a spelling mistake, there is a spelling mistake, so you can go ahead here and you can rectify and save and update. Once I saved it, now if you see, the is not came in the list, so what I will do in system, I need one blank parameter, that is this. See, I refreshed, this is here, so dial type, dial gauge, plunger type. This is one case of the enable scope. This way you can feel the dimensional scope. If you see the dimensional scope of the mechanical, this is the mechanical scope, so you can feel calipers. Now caliper. Now one more, caliper is up to 600, right? There is a list count. A list count. If there is a multiple list count is given, now dial type, just hold on. Yeah, this is a list count is, one more list count is 10 micron. So what I will do, I will go here, again I will select the same parameter, then I will leave the blank parameter frequency, then I will select the range 0 to 25, 0 to 25 mm, then list count, see the list count is 10 micron, so 10 micron, then 10 micron is this, and uncertainty is, if you see the 10 micron, this is my uncertainty, 0 to 6 micron, so 6 is, I will select 6 and I will select the micron as a unit and I will update it. So this is my another a range of dial gauge plunger type I have added as a scope. So I define my scope. Now this is way of the update the level scope of mechanical. If you see the same way up to 600 means 0 to 600. This is the uncertainty, right? Now if you go down, you can feel all these this way. Now here one more, say example weights. In weights there is no range. Now how we'll feel it? I will go in here because I do not have a parameter, so I will create it. I created the weights, right? Then I clicked on here, I refreshed the list, then source is not applicable, then I selected the weight, I kept blank frequency, then I will go on this, it is a 1 mg. So here in case 1 to 1 mg I will select it. What is my uncertainty? 0.02 mg. Now list count is not applicable because weights do not have resolution of list count. So it is a 0.02 milligram is my uncertainty and I have updated. This is called the district values, right? So you can feel these with the scope of the weight and all these ranges you need to update. Now if you see 100, 200, 1 gram, 2 gram, you can update the same way, right? This is the method of dimensional or mechanical scope updation. Now we will see for the some another examples like you take example of electrical, because electrical having some quite different scenarios. In electrical, if you see the electrical scope, we have already updated. Say example, this is the example. Now take this is DC voltage, and here if you see the parameter name is a DC voltage, have some different ranges like 0.1 millivolt to 1 millivolt, and uncertainty is 3.58% to 0.36%. Now in this case what we will do, here I will select the DC voltage, DC voltage, right? So I do not have parameter again, so I will go here, I will select electrical and DC voltage I have created. This is again my mistake, So I will rectify and I will add it now, right? So here I will refresh the list. Now this is my scope for the source method. So I will select source, DC voltage, right? Then there is a frequency, no, 0.1 millivolt to 1 millivolt. So what I will do, 0.1 to 0.1999 millivolt. This count is not applicable here. 3.8 percentage, 3.58 percentage RDG by using etc. What is the method? So this way I will add one range. Again I will select source, the same parameter, voltage. Then this is 0.199 millivolt. So I will take 2 now, and 2 to 1 millivolt. 0.221 millivolt. Then uncertainty is 0.36 percentage RDG. Right? Save and update. This way I will fill the enable scope. Now one more scenario in electrical is different case. This is for the frequency. So AC voltage have some frequencies. So this is a simple method. Again I will select the source. Here I will select AC voltage. What is my frequency? 45 Hertz to 10 kilohertz. Right? So 45 Hertz to 10 kilohertz. So 45 to 10 means 0.01. Now I will use the calculator. Frequency, Hertz to kilohertz. Kilohertz, 10 Hertz is 10,000. So I will put it here, 10,000 Hertz for 2 millivolt to 10 millivolt. So 2 to 2.99 millivolt, and uncertainty is 2.53 percentage RDG. So 2.53 percentage RDG I will fill and I will update the same. Then one more range I have to update for the same. This is a source, AC voltage. Then I have taken 2.99. So I will take a 3 to 10 millivolt, right? 10 millivolt. So this is my frequency. So what I will do here, 45 to 10,000 Hertz, 3 millivolt to 10 millivolt, and uncertainty is 0.41 percentage. 0.41 percentage RDG. And I will update the same. Now I have updated. This is my one range. This is now one range has done. Right? If you see, this is my one range has done. For this now scenario, I will show you. This is one more scenario. If you see here, 100 millivolt to 1 millivolt. So in this case, what I will do, I will select source. I will select AC voltage. That is my parameter. Then I will select the parameter 45 to 10,000 Hertz, and range is 100 millivolt to 1 volt. So 100 millivolt is equal to 0.01 volt to 1 volt. I can use the calculator, right? Voltage, then millivolt, 100 to volt, I will take 0.1 volt. So I will select the 0.1 to 0.199 volt, because there is again scenario is 0.82% to 0.03% is my uncertainty. So for the 100 millivolt is 0.082. So 100 to 0.1 to 0.19. Right. So I can take 100 now. 100.99 millivolt. Both way you can feel, in the volt as well as in the millivolt. So what is my uncertainty? 0.082 percentage. 0.082 percentage RDG. We will update the same. Right? Now again I will select the source, AC voltage, frequency is 45 to 10,000 Hertz, and range is, now what I taken 100.99, that is 0.199 to 1 volt, and uncertainty is 0.03% RDG, 0.03% RDG, and I will update this. Sometime if you see, the scope will become there is no range of frequency. Sometime some another case we will see. Now if you see the AC current and at 50 Hertz, now in this case what we will do, I will select again source, again AC current, and here it's a 50 Hertz, so 50 to 50 Hertz, we will take 50 to 50 Hertz, 20 ampere to 1000 ampere, 20 ampere to 1000 ampere, and uncertainty is 0.67% RDC. So here I have to, what I have to do, 20.999 ampere is 0.67% RDC, and I will update the same. Now again one more entry I will pass for the AC current, that 50 to 50 Hertz and 21 says 20.99 we have taken, then 21 ampere to 1000 ampere, then 1000 ampere uncertainty is 0.3% RDC, right? And I will update the same. This is one more case we have seen. For the same here also, for the capacitors same. Sometimes see another different cases. Now here inductance, I will show you this also. For inductance we have only single discrete value, we do not have the range here also. So what I will do, I do not have parameter inductance, right? So I will create the electrical inductance. I have created now. I have created the parameter. Then I will come here, I will refresh the page, then I will select the source, inductance, frequency is 1 kHz to 1 kHz, and now 0.1 millivolt, 0.1 amH, answer that is this. You can feel both way, 0.1 to 1, 0 to 0.1, right? So 0. 0.1 to 0.1999 amH, so millihenries, and uncertainty is 1.67% RDC. This way you will update this kind of scope. If you have now one more entry we have to pass, that is inductance. Frequency is again 1 kHz to 1 kHz, and now we have taken, see, 1.999, 0.199, 0.22 1 milliwatt amH, and my uncertainty is, if this till 1 is 1.16%, 1.16% RDC. Now this way you can update, then 1 to 10, 10 to 100, 100 to 1000, or else you can pass the same single entry, that is because same uncertainty is given 1 to 1000, so I can take here 1000 millihenries and the complete range I can cover, because the same uncertainty is given 1.16% RDC, the all points. So 1.16%. In this I have taken the 1000, that's why I do not need to take the, I don't need to cover these points, because this complete entire range has covered between 1000. This is one more scenario for the inductance. Now see the same scenario again. Is there any some another cases? Now this is a 50 ohm output. Now oscilloscope. So here what I will do, oscilloscope, I will create the parameter oscilloscope DC amplitude at 50 ohm output. See, I show you, I am creating the parameter oscilloscope DC amplitude, right, at 50. This way, oscilloscope DC amplitude at 50 ohm output, I have created the parameter for the electrical. I will create the same again, one more parameter AC amplitude at 1 mega ohm output, and this is my frequency at 1 kilohertz, right. So I have created the parameter. I will show you again. Source, I need to refresh the page. Source, oscilloscope, then there is no frequency, 0.5 millivolt to 2.2 volt. So then again 5 to 5.99 millivolt, and uncertainty is 1.91% RTG. So 1.91% RTG. I will update the setting. Then again I need to pass one more entry, source, oscilloscope, 5.99 we have taken, then 6 to 22 volt. Sorry, 6 to 2.2 volt. 6 is millivolt. Now again I will use calculator. Voltage, millivolt, 6 is volt, 0.06. I will copy this. Instead of I will put it here, then 2.2 volt, and uncertainty is 0.46%, 0.46% RDG, and you can update the same. This is the simplest way to feel the enable scope of the electrical. Now if you see again some different cases, I don't think so now anything is pending. This is the way of enable scope you can feel. Now here, say example, process calibrator simulation method. Now here I will create the parameter thermocouple, and then I will feel the same. I will show you this example. I will go here, and then I will create the parameter thermocouple, process calibrator thermocouple, then KJEN, K, comma, J, comma, E, comma, T, comma, etc. and type. And I will create the same. So now I will refresh the page, right. I will go here as a source, thermocouple, K type. I will select KJET type because I do not have frequency, but I can cover all these parameters. So minus 200 degree to 1370 degree is minus 200 to, now see here important thing is minus 200, and the respective higher number is minus 199.99 degree centigrade is the respective number. As far as mathematics, this is a higher number, so we have taken that, and the uncertainty is 0.035 degree centigrade, 0.035. If you see the degree centigrade I have selected, and I will apply the same. Then again I will select the source, thermocouple, K type. Now minus 199.99 to 1370 degree centigrade, right, and then uncertainty is 0.032 degree centigrade. I will save and update the same. So this is the method of enable scope operations. I have shown you some different examples. Anything else? I don't think so. It is pending. Then for the thermal is a similar way. For thermal scope is the same way. You can feel the thermal. There is a range and uncertainty degree centigrade percentage RH. relative humidity. If you can search the by parameter wise. Now I want to show the DC amplitude. What is my I have field. You can search by the parameter wise also. So this is the NABL's scope updation method in two sections. I repeat it again by summary. I will create the first certificate, then I will add the details by clicking here. If you see, we have now updating these few NABL certificates, few ranges of NABL certificates. Units are very approximately, units are very important at everywhere, as well as frequency is important. If you are not putting the frequency, no issues, but if you are putting, make sure it is correct or not. Right? Thank you.